Hello everyone, my name is Balint Ujvari and I work at SolarPunk as a software developer. We are responsible for business development and creating applications on the Swarm network, and today I would like to talk about dApps and how to make them fully decentralized. So first of all, let's start with the current state of the applications. Unfortunately, only a small portion of the internet users interact with dApps regularly, and to be honest, I think they have a good reason for it. First and foremost is that they have a lot of trust issues, because whenever any information gets into the media, it's either really good or really, really bad. I'm sure most of you have heard about a lot of scams, frauds, and data leaks, and people are afraid of this. And the other thing is that most of the people don't really know and understand the usual blockchain jargon, like tokens, incentivization, signatures, signing transactions. And I don't think they really care about that much. They just want to have the usual experience that they have in Web2 user interfaces. And on the other hand, I understand as a developer that it's really hard for the devs to create such applications that are really similar and seamless, just as the Web2 applications, because every other day there is a new protocol coming out, a new version, an update, and we have to keep up with these solutions to have the state-of-the-art applications that we want to achieve. And for this reason, I think the issue isn't that the Web3 has wrong ideals. The problem is that the execution and how we create these applications. In this image, you can see that usual user flow is that the user signs into the mobile application, or opens a browser tab, opens the plugin, and then he or she has to connect into a storage solution, or maybe access a server, then set up a RPC and communicate to the blockchain, create a transaction, sign it, and then you can receive his or her funds, which is really complicated. And what I would say is that all of the right side of this image can be abstracted away on the UI side, and the user doesn't really have to care about what goes in the background. He just has to care about what he sees and understands as a regular everyday user. It would be really hard to explain to my mother, for example, what a token is, why would she need to use another cryptocurrency, which storage solution is better, which blockchain does she need to use, etc., etc. That's one thing. And the other thing is that most of the Web3 applications, unfortunately, still use centralized storage solutions like S3 or Google Cloud or any kind of custom server, which is really a problem because the blockchain ecosystem, we really like to focus on privacy and censorship resistance. And these companies are not really famous for that. It's not that I don't like them, they just have these kind of problems. And data leaks have happened in the past several times. And what I would argue is that full decentralization is really achievable now without sacrificing the usability that we are used to at the Web2 space. I don't think we need to discard every aspect of the Web2 space. We just have to transform them into the Web3 world and provide a bridge where we can access our data and own our data ourselves. And for that, I would like to talk about Swarm a little bit and introduce you how to store your data in a decentralized manner. So what is Swarm? Swarm is a peer-to-peer network of nodes that collectively provide a censorship-resistant and decentralized storage system with some communication services. And what is B that I'm referring to here in the slide? B is just an implementation of a Swarm client with which you can access the whole Swarm network. Swarm currently now has around 8,500 nodes last I checked. So we can say that we are quite decentralized as of now. So we had a talk previously, we've heard it, that users don't really like remembering passwords and they keep forgetting it. And I agree with that, that it's really hard to explain to them why they need to do this all of stuff just to set up a wallet, go through this onboarding process. And in my opinion, the worst part is when we are losing customers, clients during the onboarding process because it's too complicated for them and they don't trust our applications. And for that, the first thing I think is that we need to create seamless wallet creations in the background. The user doesn't really have to know that the wallet is created at the background. For example, they can just sign a transaction using their fingerprints by just creating on the device passkey, and that's it. They don't have to know anything else about that. And how to apply it into the decentralized storage solutions. You can wrap your B nodes into mobile applications, just basically next to your MetaMask application or any kind of Web3 service you want to use. And then that way it can directly communicate with the storage solution that you have, in this case Swarm. And then you don't have to worry about which server is going down in the background, because then you always have a decentralized service which is always available. You can also do the same thing in the browser using a plugin next to, again, with the MetaMask plugin or whichever service you want to use. And by the way, at SolarPunk and Swarm, we are working on a solution right now which compiles the whole B client into WASM, which can then be integrated into a plugin seamlessly. And again, the main point here is that all these things can be hidden away, abstracted away on a high level from the user. They don't really have to know what is going on. But they still care about where their data is stored and how private it is, who can access it. So I would like to talk about a little bit about the data that exists on Swarm. You can think of any kind of data that can be uploaded to Swarm, let it be video, document, picture, literally anything. And on Swarm, everything lives as a chunk of 4 kilobytes. It has a fixed size and immutable. What does this mean? Whenever my mother wants to send a picture of her favorite cat to me, then she has taken a picture of 4 megabytes. Then it's going to be split up to, if my math is correct, around 10,000 or around 1,000 chunks of 4K, and each chunk is going to be hashed into an address hash and pushed up to the Swarm network, providing a root hash that you can access your data from. This means that you can upload any kind of data, but you still need to know who owns that data. And for that information, Swarm introduces SOCs, which is short for singular chunks. Singular chunk is a specific type of data living on Swarm, which can be only uploaded by the single user who owns that node, who has the private key to that node. And by that, we are able to prove who owns the data, providing a self-sovereign infrastructure. And later on, I can show you how to use it in modern website applications. So let's see. Now we know how to upload data, how to prove that it's ours. Then we need updatability. Updatability doesn't mean that the data is mutable. It means that we can add or append new data to the existing structures. Remember, content address chunks are immutable. So singular chunks combine in a clever way, are combined in a clever way into data structure, which provides you a static address that you can access from the Swarm network. Under the static address, you can access your mutable or appendable content. And with this solution, whenever you, let's say, want to create a blog post or a new website, you just upload the whole website to the Swarm network, upload that hash that you have created from your website under that feed, and then you can access that address, that feed under that address. So what do you need for a feed? You just need your public key and the topic that you can identify with your website. And then you can access everything under that feed whenever you update it. Now we have a problem. We are bound to Swarm, and whenever someone wants to access this Swarm feed, then the user needs to have access to a gateway or a local node. But we have a solution if we bind or point a Swarm address to an ENS address, and then you can access this feed from the outside world, just like you would use it for Facebook. So in this example, let's say you upload the whole website of Facebook to Swarm, bind it to an ENS address, and there you have it. You can access it from the outside world. But then we still also have a problem that how do we get notified about the updates of, for example, the blog posts of Vitalik or anyone else. We need a notification system for that, which Swarm also provides. There are several methods. For example, the first and most obvious one is using feeds. You can just use the Web2 methods. You can poll the feed, and whenever the underlying hash changes, then you know that there has been an update, and you fetch the website. But there is a more elegant way than from that, which is the GSOC, the Graffiti Singular Chunks, which is really just an analogy on the Swarm network to the graffitis on the wall. You just spray a new graffiti on top of the pre-existing one, and the outermost painting, or in this context, the outermost chunk, the latest chunk, is going to be the latest update on that GSOC address, and that's how you provide a subscription, a notification service on the Swarm network easily. There is another solution that I haven't described here, which is called the Swarm Postal Service, which is the most secure way of delivering messages completely encrypted, but I haven't put it up there. So now we can create websites, put it on the Swarm network, notify the users, but why would the other nodes on the network store my data? Well, Swarm has a protocol, an incentive system just for that. And we have an analogy, again here, called postage stamps, because these are just the same thing conceptually to the real world stamping mechanism. When you buy prepay, basically, a postage stamp on the network, then you stamp this data with this batch you have bought and upload it to the network. And then you are going to have a proof that this data is going to persist on the Swarm network, provided the token that you have paid on the network. But then we have, again, another problem, that most of the Web3 applications are on different blockchains using different tokens, cryptocurrencies, different protocols, which is really a problem. And if you want to have a decentralized, generic data storage solution, then you're going to have it support multi-chain. And Swarm has recently released its multi-chain support, which is a really good thing, but because if you have different applications, trusted execution environments, decentralized AI, they all can use the same storage solution as Swarm and access the same data, which is really nice. And all the postage stamp and token bridging swapping is done under the hood. Again, I really want to emphasize that the user doesn't have to know about bridging, swapping, because they don't really understand it, to be honest. They just care about they don't even care about buying a postage stamp, you know. They just want to have, let's say, a Google Drive with 10 gigabytes of capacity for 1 year, and that's it. That's all they want to care about. And Swarm provides a way that it's possible, but a good user experience can be derived from the Web2 world. Okay. Okay, now that we have websites, we can update them, we can store them on the Swarm network, the nodes are incentivized. Now we have the problem that we need access control on the network. I don't know if anyone has had this problem before, but it happened to me that a while ago my mother wanted to send a picture to me on Facebook, but accidentally she didn't DM it to me, she posted on my Facebook feed, and it was really inconvenient. And for that reason, I think we need a correct way of controlling access by the users and who can grant access to the recipients they want to send a message to. And for that, Swarm natively supports access control. It's really, again, an analogy to the solution that exists in Google Drive, where you type in the recipient's user address. By that I mean the email address, and on Swarm you just replace the email address with the public key of the user. You just click on share, the user is granted access, and then you can just you can just share that encrypted hash with the recipient. And even though even if it gets leaked somehow, then only you and the recipient can download that encrypted data, which is really nice. And again, it's a really flexible system because it allows Unix-like access control structures like grouping, who can access what folder. The admins can assign rights to different organizations. It's really dynamic. So at the end, I want to talk about that what else do we need if we want to have a really robust system, because in the Web 2 world, this robustness and redundancy is achieved by backup servers. If there is a network outage, then usually big companies like Google have backups, and then you can access the data and fetch everything from the backups. But in a fully decentralized system, you really don't have a solution for that. But Swarm, fortunately, provides redundancy in that case. So here I would like to talk about a little bit the concept of neighborhoods. So whenever you upload data, it's going to have an address hash, and the nodes that store this data also have an address hash, and these nodes and data live in the same address space. And each node, which is in a predefined proximity of the data, is responsible for that node, for that data to be stored. This way, redundancy can be defined as an area of responsibility within the Swarm network. And there is one other thing, which is called erasure coding. Erasure coding is an optional feature of Swarm, but if you want to make sure that your data lives there, even if there is a pretty bad outage in the whole network, for example, the highest level of erasure coding is called paranoid, and if you upload your data to the network with this paranoid configuration, then even if half of the network goes down, it is guaranteed that you're still gonna receive and fetch your data because the erasure coding provides it. It's really similar to the concept of what the DVDs and CDs use when you scratch the surface of them. It's really the same analogy here. And lastly, what are the next steps? I think the first and foremost thing is we need to narrow the educational gaps, because as in the previous talks it was mentioned, most of the people really forget passwords. They need to know why they need, what they need, how they can use these tools. They don't really need to understand what a transaction is, what a signature is. They have to have a higher concept, and we need to educate our developers also to help the users onboard our services, because without mass adoption, we don't really have a way of going forward in this ecosystem. And also, I think, as I mentioned earlier, we need to integrate our Web3 services into our mobile applications, into our browser plugins, so that the everyday user doesn't have to care about how to connect to an RPC node, how to configure data storage solution. Everything has to be abstracted away from the user. And lastly, I think I've heard about great talks in the past couple of days about decentralized AI, and it is really great that there are domain-specific AIs, but I really would like to see that these AIs use a decentralized solutions for the data storage, because that would mean full decentralization in every aspect of your services. And if I'm right, then we can show you a demo, if the guys can open the link in the background. So my colleague has started a stream at the start of this presentation, which is fully hosted on Swarm, and it should be live if the guys can show it. Yep, that's me. It's a bit lagging because of the bandwidth, but it's going live on Swarm. Audio is not displaying now because we don't want to interrupt the sound here. But I just wanted to show you that we have a working real-life solution with streaming on Swarm. And I think that's it. Thank you very much for your attention. And if you have any questions, I'm happy to answer.
Thank you, Balint. Do we have any questions?
Can you talk a little bit about like what kind of applications, like any examples that you know, like either SolarPunk or some others created with you know, with using these and actually how they can achieve it. So what can SolarPunk can provide for builders to create such applications?
Yeah, for sure. For example, we have created for previous conferences. We were at, for example, at Bangkok last year. We have created a whole website hosted on Swarm, where you can see the agenda of the whole conference. Everything is updated. Everything was updated live, or just you can see that we have a streaming solution, or you can have a blog post that we have created, websites. Everything is possible, and at SolarPunk we are responsible for helping the customers building these applications.
Anyone else? If not, please warm round of applause for Balint.
Thank you.